So this video is going to be, I'm going to be working through the problems for the midterm practice test. I will be explaining what I'm doing, but I'm not going to really be teaching the material because I've already taught it in the earlier videos. So this is more or less just working through some problems. And I printed out the practice test review problems, and I have the answer key. So as I work at each problem, I can check my answers. I want to make sure I don't make any mistakes. So the easiest way might be, I could just show you, like here's the first problem, the practice test review problems. So use the quadratic formula to find the real solutions. So actually, if I have room, I can actually try and work it out here. So the quadratic formula will be, it's negative b plus or minus b squared minus 4ac over 2a. So for our equation, a is 1, the coefficient for the squared term. B is going to be 4, and C is negative 6. So I'll simply plug in A, B, and C into this equation and then simplify it. So negative B, negative 4, plus or minus B squared, it's 4 squared, which is going to be 16, minus 4 times A, which is 1, times C, which is negative 6, all over 2A, which is 2 times 1. So if I look inside the square root, this is a multiply here. So negative 6, and I'm subtracting it, so it's going to be plus 24. So 24 plus 16 is 40. So I believe it should be, of course, I need to simplify this. I guess 4 times 10 is 40, so a 4 comes out as a 2. And 2 is a common factor, so I believe that should be the solution, which it is. Second problem. Looks like another solving this quadratic equation. So if you look at the answers here, it's just asking for the solution set. So it's pretty straightforward. So this is just like number 1. I guess in this case, A is 1, B is negative 4, and C is negative 2. So using the quadratic equation, which once again is up here, negative b, so a negative, and since b is negative 4, it's really a negative 4 plus or minus b squared, which is 16 minus 4 times a times c, which is negative 2, all over 2a. So now a negative 4 is just 4. So this is -4 times -2, which is 8. So it's 24. If I simplify the square root, 6 times 4, 4 plus or minus 2, square root of 6. This is actually pretty similar to the previous problem. So if I cancel out a 2, 2 plus or minus square root of 6. Once again, that's correct. Number 3. So here, it's like a rational expression with complex numbers. And they want us to write this in a plus bi. So the idea here is that in the world of math, they don't like to ever leave any i's in the denominator. So in this case, hopefully you remember the way we can get rid of this I out of the denominator is to multiply by the conjugate, right? So the conjugate means the terms are the same, but you just change the sign in the middle. So if it's 2 plus I, the conjugate is 2 minus I. But of course, I have to multiply the top and the bottom by 2 minus I. Because the idea is this whole fraction here really equals 1. So I'm not really changing the value of this. I'm just going to change how it looks. Now, if I multiply the denominators, now you can FOIL this, but whenever you multiply conjugates, there's a shortcut that I always use. And the shortcut is you take the first term. Of course, the first term is the same for both. So say the first term, doesn't matter which parenthesis I'm looking at. You take the first term and you square it. Then you always write a subtract. And then you square the second term. Now the top, I go and I need to FOIL it. So 2 minus I times 2 minus I should be 4 minus 4I plus I squared. So now it's a matter of simplifying. So when the top, I squared is -1, so it's 4 minus 1, so it's 3 minus 4I. I squared here is -1, so I'm subtracting a -1, which is +1. So 4 plus 1. Now the thing about these complex numbers is, and you notice here, they want the answer to be 2 terms, a real part and an imaginary part. Right now, this fraction, it's almost like 1 term. So I need to split this up into 2 fractions, because when I do that, then I have it in the form they want. And when I check the answer, that is correct. All right, find the real solution to the following equation. The cube root of 2x plus 3, then -4 equals -1. So problems like this, the first step is you want to get the radical by itself on one side. So I'm going to add 4 to both sides. So I have the cube root of 2x plus 3. Add 4 to both sides. The right-hand side becomes 3. Now my ultimate goal, when we say solve this equation, the ultimate goal is to have x equals something. X equals a number. So I want to get x by itself. Right now I can see that x is sort of, I like to say, stuck under the radical. So I need to somehow free x to get x out of the radical by itself so I can solve for it. So what I really want to do is I really want to get rid of this cube root, this radical. So the way you do it, if I have a cube root, if I take that whole thing and cube it, when you cube, a cube root, sort of like they cancel each other out, and you're just left with what's under the radical. Of course, if I cube the left-hand side, I also have to cube the right-hand side. So the left-hand side simply becomes 2x plus 3, and 3 cubed, 3 times 3 is 9, times 3 is 27, is 27. So now, hopefully you can see that it should be pretty straightforward to now solve for x. If I subtract 3 from both sides, if I divide both sides by 2, I'm saying my solution is x equals 12, which is correct. All right, here's another problem where basically trying to solve the equation, solve for x. Of course, you notice I have an x under the square root. Then I've got this x also over here. The way you go about solving this is the same principle as the problem before. Whenever you have a radical in one of these equations, you want to get the radical by itself on one side. So let me subtract 2 from both sides. So I have square root of 3x minus 2 equals x minus 2. So this x on the right-hand side is fine. I can try and solve for that, but I've also got an x under the square root, which I need to get at. So really what I want to do is get rid of this square root. So how do you get rid of a square root? Where you square it. So I'm going to square the left-hand side. Of course, I also have to square the right-hand side. So the left-hand side, when you square a square root, you're just left with what's inside. The right-hand side, I'm going to multiply this out. So this is x minus 2 times x minus 2. So if you like FOIL it, I'm going to skip a step, see if I can get this correct. I think you should end up with x squared minus 4x plus 4. Now, the good thing is there's no more radicals, but now I can see that I'm going to have like a quadratic equation because I've got x squared here. The way I solve a quadratic is let's move everything to the right-hand side. So we get one side equal to 0. So I'm going to subtract 3x and add 2. So if I subtract 3x, I get minus 7x. And if I add 2, so now I need to solve this quadratic equation. Now, of course, there's multiple ways to solve a quadratic equation. And I'm thinking this actually might factor. And if it factors, then that's a pretty easy and quick way to solve it, right? Because if my product is 6 and my sum is -7, this is the way I solve these quadratics. Two numbers multiplied together equal 6, but when you add them equal -7, how about -1 and -6, right? When you multiply them at 6, when you add them, it's -7. So this factors into x minus 1 times x minus 6. So it looks like our two solutions are going to be 1 and 6. However, and actually I should have checked on this problem, whenever you're solving an equation, it starts with a radical. When you get your solution, you always need to check it because sometimes, even though you did the math correctly, you will have what are called extraneous solutions. So those are solutions that aren't really solutions. And the only way you can check that is if you go back and plug them in. So actually, I should have done this for this problem. Maybe I'll go back and do it. So if I plug the 12 in for x, 2 times 12 is 24, plus 3 is 27. The cube root of 27 would be 3. and that's correct. So here I need to do them one at a time. So let's take x equals 1. So if I plug it in here, 2 plus square root x is equal to 1, 3 minus 2 square root of 1, does that equal 1? And actually, you know what? 2 plus square root of 1 is 3. Unless I've messed up, I don't think 1 is a solution, right? Even though I did the math and I solved it, when I put the 1 back in here, it actually doesn't work. So this is what happens. That's why whenever you solve an equation where you start with a radical, you have to check your solutions. And I forgot to do it at number 4. I should have. Thankfully, x equals 12 is a solution. But for this one, actually 1 is not a solution. Now let's try and see if 6 works. So if I plug in 6 for x, I have 2 plus square root of 3 times 6 minus 2 equals 6. So this is 18 minus 2, which is 16. 2 plus square root of 16. Does that equal 6? Well, square root of 16 is 4. 4 plus 2 is 6. This one checks out. So as it turns out, we have one solution, which is 6. So once again, quickly, just to review that. I did the math correctly, and the math gave me 2 solutions. But whenever you have a problem where you're solving with a radical, when you find your solutions, you have to go back and check them one at a time because they don't always work. And that's what happened here. All right. Number 6. Find the real solution of the following equation by factoring. So the nice thing is they tell you it factors because this is 4 terms. So especially with these numbers, it'd be hard to know if it factors or not. But since I said it factors, let's go ahead. Now, when you factor 4 terms, it's called factor by grouping. So let me see if I can fit it in up here. Factor grouping means you factor, you break it up into 2 groups of 2, and you factor. So here's the first one and the second one. So it's like you factor them separately. Then after you factor them, you can look and see if it's going to work. So here I want to find a GCF, x cubed minus 9x squared. Looks like the GCF would be x squared. So I factor out an x squared, I'm left with x minus 9. Now I look here, it's not obvious at first, but if you grab your calculator, we can see if 81 goes into 729. So I'm simply going to take $729 divided by 81 and equals 9. So it turns out I can factor out since it's minus here, I'll factor out a negative 81. So x minus 9. So 81 times x minus 9 would equal negative 81x plus 729. And then the last step is, if these 2 parentheses are identical, then you can actually factor out the parentheses. So you factor out x minus 9. And then in your next parentheses, you would put x squared minus 81. Now, if I'm trying to solve this, actually, this parenthesis here can be factored. Again, so it's really x minus 9. This is a difference of squares, x plus 9. So when you factor it, you get this. You notice these parentheses are identical. So in terms of a solution, you get 9 and negative 9. And that is correct. All right. Next, here's a equation that has an absolute value. So absolute value of 2 minus 2t, then plus 3 equals 13. So this is an absolute value equation. The lectures I showed you, the way I like to solve these, what you do is, first thing you do is you get the absolute value by itself on one side. So I'm going to subtract 3 from both sides. And I have absolute value of 2 minus 2t equals 10. And then what you do is you actually break this up into 2 separate problems. The first one is you just drop the absolute value signs. And in a minute, we're going to solve that equation. In the second equation, you also drop the absolute value signs, but then you make the number over here a negative number. So let's take this first equation and solve it. So 2 minus 2t equals 10. If I subtract 2 from both sides, I get negative 2t equals 8. Divide both sides by negative 2, t equals negative 4. So that should be one solution. I take my other equation, 2 minus 2t equals negative 10. Subtract 2 from both sides, negative 2t equals negative 12. Divide both sides by negative 2, t equals 6. So that should have 2 solutions, negative 4 and 6. And that is correct. Eight, we're still dealing with the absolute value, but now it's an absolute value inequality. So the way I like to do these, maybe I'll try and do it. I think I have room here, maybe. Sort of like the same thing we just did. You first get the absolute value by itself on one side, which it already is. And you break it up into 2 problems. The first one's pretty straightforward. You simply drop the absolute value signs. And in a minute, well, maybe we'll do it right now. You solve this inequality. And that means you basically get the x by itself on one side. So if I subtract 5 from both sides, if I divide both sides by negative 2, now you got to remember the special rules. Whenever you multiply or divide both sides of an inequality by a negative number, you can do it, but when you're done, you have to flip the inequality. So remember, whenever you multiply or divide both sides of an inequality by a negative number, you can do it, but when you're done, you have to flip the inequality. So I'm going to divide both sides by -2. Becomes x less than -3. Now in a minute, we're going to draw a number line and we're going to graph this. But for now, let's go back to our original inequality. So this was the first solution. The second one, you drop the absolute value signs. And here's what you do. You go ahead and flip the inequality, and you also make the number a negative number. So it's like three things, right? You drop the absolute value signs, you flip the inequality, and you make the number a negative. So you end up with this, and now we're going to solve this by getting x by itself. So if I subtract 5 from both sides, now to get x by itself, I need to divide both sides by -2, which means I can do it, but I have to flip the inequality. So -16 divided by -2 is 8. So now what I'm going to do is I have these two solutions, these two inequalities. I'm going to graph them on the same number line. And when we do that, then we'll be able to determine what the solution is. So here's a number line for x. I'll just stick -3 here, 8 over here. So this first solution says x has to be less than -3. Well, that means at -3, I put a parenthesis, and since it's less than, I head in the negative direction. And x greater than 8, I go to 8, and I put a parenthesis, and then I have to head the positive direction. Now for this kind of problem, if this is what happens, if you have two distinct regions here, as it turns out, the solution, you have to union these two intervals. So for this one, I could say it's -∞ to -3 union 8 to infinity. And that is correct. All right. Next one. Way down at the bottom of this page. Story problem. Betsy, a recent retiree, requires $5,000 per year in extra income. She has $50,000 to invest and can invest in B-rated bonds paying 17% per year, or in a certificate of deposit paying 7% per year. How much money should be invested in each to realize exactly $5,000 in interest per year? So story problems, let me write down the information sort of in my own words. So she has some money to invest. She has $50,000. She has two options. She's got one account that offers 17% interest, and then another account that offers 7%. Now it doesn't say here, but maybe the kind of thing where maybe the 17% is a bit riskier, the 7% is safer. So she's trying to decide how to divvy up her $50,000, how to invest it, with the goal she wants her interest per year to be $5,000. So at the end of every year, she must be able to go and see that she's made $5,000 by just putting her money into these two investments. Let's do this. Let's go ahead and we'll call the amount, wow, the amount that she's going to put into this 100% account, we'll call it X. We don't know how much it is right now. We'll just call it the variable X. So now if we look at how much, if she puts X in the 17% account, then how much does she put in the 7% account? Well, she has a total of $50,000. So if she puts X in the 17%, then it makes sense, right, that she would put $50,000 minus X in the 7%. Now, the way they calculate interest, the simple interest equation is I, P is the principal, how much money is in the account, R is the interest rate, and T is the time in years. Of course, for us, we're just looking at 1 year, so T is 1. So what we need to do is, let's figure out the interest that we make from each account. So from the 17%, you take the amount of money you have invested, the principal, which is X, and you multiply by the interest rate as a decimal. So 17% as a decimal, when I do math, I rewrite it as 0.17. And then the number of years it's invested, in this case, is just 1 year. So if you think about this, the amount of interest from the 17% account is 0.17x, where X is the amount of money you put into that account. For the money in the 7% account, here's the amount of money you invest, 50,000 minus X, and you multiply by the interest rate. 7% written as a decimal is 0.07. And of course, it's also 1 year. What I'm going to do here is let's go and multiply out these parentheses. So I'm going to grab my calculator. So I need to take 50,000 times 0.07. It's 3,500 minus 0.07x. So here's the interest from the 17% account. And this is the interest from the 7% account. Well, the ultimate goal is to have a total of $5,000 of interest. So that means you must take the amount of interest from the 17% account and you add it to the amount of interest from the 7% account, and it should equal $5,000. So here's the interest from the 17% account. Now I'm going to add to it the interest from the 7% account. And now I have an equation where I can solve for X, and X is going to be the amount of money that I have put in the 17% account. So I'm going to subtract 3,500 from both sides. 0.17x minus 0.07x, it's just 0.1x. If I want to solve for x, divide both sides by 0.1. And when you do that, turns out x is $15,000. So this is the amount of money that's put into the 17% account. So if it's $50,000 total, you realize that $35,000 has to be put in the 7% account. All right. Story problems are always a little tricky. Hopefully, you're able to follow what we did there. All right, ready for number 10. Another story problem. It says Trent can deliver his newspapers in 10 minutes. It takes Lois 40 minutes to do the same route. How long would it take them to deliver the newspapers if they work together? I always, this kind of story problem, I call it the work story problem, because usually it's like people doing a job. So the idea is they can each do it by themselves, and it takes Trent 10 minutes to do the job by himself. Takes Lois 40 minutes to do the same job. And then the question is like, well, hey, how about if they work together, how long would it take them? This kind of story problem a few years ago I used to struggle with, but then I came up with a pretty straightforward equation that you can use for this kind of problem. So let me write it out and I'll explain what it is. 1 over T1 plus 1 over T2 equals 1 over T sub T. What does this mean? Well, T1 is the time it takes the first person to do the job by themselves. T2 is the time it takes the second person to do the same job by themselves. And then T sub T is the time it would take them if they did the job together. So for our problem, if Trent can do it in 10 minutes, we'll call Trent T1. So 1 over 10 minutes. T2 is the time it takes Lois to do the same job. It took her 40 minutes. And then T sub T is the time it would take them to do it together. So now we have an equation we can solve. Different ways to solve it. Let me just write it out, maybe without the units. So we have 1/10 plus 1/40. I'll just call this time here. Someone might want to clear fractions. What I'll probably do, I think I could pretty easily just add these fractions together. You need a common denominator, right? Which is going to be 40. So I need to multiply this. If I multiply this fraction by 4 over 4, I can actually do it pretty easily. 1/10 becomes 4 over 40. So now I add these together. 5 over 40 was 1 over T. And just, once again, different ways to solve this, just for fun. Whenever you have two fractions equal, you can cross multiply. Just for fun, I'll cross multiply. Then if I divide both sides by 5, So this says if they actually did the job together, it would take them 8 minutes. That is the correct answer. All right. Question on domain. So once again, I'm not going to take the time to really explain what the domain is, or even how we come up, how I taught to solve the domain. Instead, I'm just going to do it. So here, the function, I notice I have a variable under the square root. So what I taught before was basically what I'm going to do is I'm going to take what's under the square root and write it out as greater than or equal to 0. Then I just solve this inequality. And when I solve this inequality, that will be my domain. So once again, if you want to have it explain why I do this, then you need to go back and watch the video lecture on domains. So I'm going to add 42 to both sides. Divide both sides by 7. And what I normally do is once I get my inequality, usually I want the answer as an interval, but I like to graph it out and then I can make sure I have the correct interval. So my domain is going to be when x is greater or equal to 7. So 7's right here. That's my domain. So as an interval, starts at 7, includes 7, and goes to infinity. Up another domain problem. This one's a little more interesting because notice here we have square root of t minus 5 over 3t minus 18. We actually have both the conditions that we look for. We have a variable under the square root. And we also have a variable under the denominator. So I have to take into account the effect of both of those on the domain. First thing I'll do is factor the denominator. Eventually, we're going to look at the denominator. For the actual domain, I always start with the square root. So once again, I take what's under the square root and I write an inequality that says t minus 5 has to be greater than or equal to 0. So here I'm making sure that whatever is under the square root is always a positive number or 0. So if I solve this, add 5 to both sides. I'm actually once again going to sketch the graph of this. T greater than or equal to 5. So from the square root part of the function, this is the domain. So it's basically all numbers 5 or greater. However, we're not done because we also have to take into account the effect of having a variable in the denominator. And the key there is we simply ask ourselves what value of t would cause the denominator to be 0. Well, I know t cannot equal 6, or that happens. So therefore, for my domain, the number 6 cannot be in the domain. If I go to my graph and I sort of just say, well, where is 6 at? 6 would be right here. Now, if it's left up to the square root part of it, 6 is perfectly fine in the domain. But the denominator says, sorry, we can't leave 6 in here. It's not part of the domain. So what you do is, in a sense, when you combine these, so you start at 5, and you go up to 6 and you stop, But what you do is you hop over 6, because 6 is the only number that's a problem. And then you keep going. So if you want to write this as an interval, you already got 2 intervals here. Starts at 5 and it goes to 6. And then it jumps over 6 and picks up again at 6 and goes to infinity. So that should be the domain. All right, difference quotient. So they give you a function, and based upon that function, they want you to figure out, plug the function into this expression, and that's called the difference quotient. So let's do that. It's going to take a little bit of algebra. Might get a little messy. Let's do it like this. Let's break it up. Let's first figure out what f of x plus h is. And then we'll look at f of x, and then we'll subtract them and go from there. So here's my original function, x squared plus 7. Let's figure out what f of x plus h is. So what this says is, in your function, every place you have an x, you replace it with x plus h. So x squared plus 7 becomes h plus h squared plus 7. And we'll go ahead and multiply out these parentheses. So x plus h times x plus h ends up being x squared plus 2xh plus h squared. And of course, you still have the 7. So f of x plus h equals this. So now the difference quotient it's f of x plus h. So this whole thing, x squared plus 2xh plus h squared plus 7. So there's f of x plus h minus f of x. So subtract, and you just write in the original function and all of that divided by h. Now it's a matter of simplifying. So you realize when we're subtracting this parenthesis, this is going to be like a negative x squared and a negative 7. So I have x squared here, but minus x squared, you know what happens? The x squareds actually cancel out. So 2xh, nothing I can do, plus h squared, no like terms there. However, the 7, it's 7 minus 7, 7 minus 7 is 0, so it's like those cancel out. So in the top, all I'm left with is 2xh plus h squared divided by h. And now I can simplify this because h is a common factor in all these terms. So the difference quotient should end up being 2x plus h. All right. On to 14. So suppose that the revenue are in dollars from selling X cell phones in hundreds. So here's an equation for the revenues. How much money is brought in when they sell X cell phones? So if they sell 10 cell phones, you plug in 10 for X and you can figure out how much money they're going to bring in. The cost C in dollars from selling X cell phones in hundreds is this. So whenever you have a product, when you sell it, you bring in the revenue. The revenue is how much money people pay you when they're buying the product. But the cost is how much money you had to put into it to make the product, right? So the profit is, you can see in part A, is the revenue minus the cost. So the profit, how much money you stick in your pocket, is the revenue, how much people paid for the stuff, minus how much it cost you to make the stuff, right? So they're saying find the profit function. So in other words, they've given you R of X and they've given you C of X. So we're just to subtract them and then we'll know what P of X is. Maybe I'll try and do it right here. So R of X is negative 1.4 X squared plus 209 X. And minus, now be careful, I'm going to put it in brackets because I'm subtracting all the terms, minus C, and C is 0.04 X cubed minus 2X squared plus 45X plus 250. So this is R minus C. And what I should do is combine like terms. Now remember, all four terms, these brackets, you have to include the impact of subtracting it. So in terms of X cubed, I only see the term here. So we're going to say that it's negative 0.04 X cubed. Now X squared, I got negative 1.4 X squared. Since I'm subtracting a negative 1.4 X squared and 2X squared. So it looks like 0.6 X squared. Now the X term, I got 209 and subtracting 45. Don't want to trust my head on this. I don't want to mess up. 209 minus 45, 164. And then I have subtracting 250. So that should be the equation for my profit. And I'm going to check. I don't want to keep on working if I made a mistake there. So I'm looking at the answer and the key, and it is correct. That's good. So that's the first question. Find their profit function. Part B, find their profit if X equals 17. If X is 1,700 cell phones are sold. So you notice up in here, when they say X cell phones are sold in hundreds. So that means if X is 5, that really means you sold 500 cell phones. If X is 10 times 100 to 1,000, we just sold 1,000 cell phones. So they're saying if X is 17, so really you sold 1,700, but for these equations, we just plug in X equals 17. So in my profit equation, I plug in 17 for x, so minus 0.04 times 17 cubed plus 0.6 times 17 squared plus 164 times 17 minus 250. Now this is definitely one where you're going to want to grab your calculator. So I'm just going to try and do this calculation. It'll take a minute, and then I'll see if it's the correct answer. So 17 cubed times 0.04, a negative 0.04. And then 17 squared times 0.6 and then 164 times 17 minus 250, and yet all those together. And the good news is, looks like my answer is correct. So it's $2,514.88. So that's the profit when X is 17, which means that's the profit when you sold 1,700 phones. Interpret P of 17, well, we need to look at the possible answers, see what they are. I just said it. When 1,700 cell phones are sold, the revenue is given by P of 17. That's not true. It's not the revenue, it's the profit. When 1,700 cell phones are sold, the cost is given by P of 17. That's not correct. When 1,700 phones are sold, the profit is given by P of 17. So it's got to be C. All right. I think there are 29 questions. I think we're almost halfway. What I might do is stop this video and then start a new one so this video doesn't go too long. So when we come back, we'll pick up with problem 15, which is interpreting the graph of a function. All right, so we'll stop now and pick up with the next video.